Okay, so hello everyone. So the topic is cyclic convolution, also known as circular convolution, using CRT, that is Chinese remainder theorem. Okay, so let a sequence is given. Sequence H is defined by elements H0, H1 up to Hn minus 1. So this is the endpoint sequence, and let these are representing filter coefficients. And the data sequence X, it is also endpoint sequence. It is given by x0, x1 to xn minus 1. These are data sequence. So cyclic convolution is expressed as, that is SP is equal to H circle, and this is the sign for circular convolution, X, and that is given by HP into XP mod Pn minus 1. So this is the direct form of doing the circular convolution. Okay, so the output samples S of I are given by summation k is equal to 0 to n minus 1 h of I minus k double bracket x of k for I equal to 0, 1, 2 and minus 1. So here double bracket I minus k denotes I minus k mod n, I minus k mod n. So alternatively, this cyclic convolution can also be computed using CRT. So using CRT, you have to take the modulus m of p as p of n minus 1. Okay, and the remaining steps are same. So this can be best explained by taking an example. So the example is, construct a 4x4 cyclic convolution algorithm using Chinese remainder theorem, that is CRT, with m of p is equal to p raised to power 4 minus 1. So that can be factorized the following way, that is p minus 1 into p plus 1 into p square plus 1. Okay, so we have to perform 4x4 cyclic convolution. So let HP is given by H0 plus H1P plus H2P square plus H3P cube, and XP is given by X0 plus X1P plus X2P square plus X3P cube, 4 sequences in each. Okay, so this modulus is having 3 factors, so I can write m of 0p is equal to p minus 1, m of 1p is equal to p plus 1, and m of 2p is equal to p square plus 1. Okay, and in the next step, that is step 2, I have to calculate capital M of ip, that is equal to m of p divided by m of I, small m of I, p, for I equal to 0, 1 and 2. Okay, so I am calculating directly because in the my previous example, that is vinaigrette algorithm, I have exhaustively computed all this thing. So this time I am directly putting the values. Okay, so m of 0p is equal to p cube plus p square plus p plus 1. M of 1 p will be p cube minus p square plus p minus 1, and m of 2p, that will be equal to p square minus 1. After calculating capital M of IP and you are having the values of small m of IP, you have to calculate capital N of IP, following the process that was discussed in my previous video lecture, that is vinaigrette example. Okay, so you have to compute this for I equal to 0, 1 and 2. So this time also I am taking the values directly, so n of 0p will be 1 by 4, n of 1p will be minus 1 by 4, and n of 2p is equal to minus 1 by 2. In the third step, we have to compute h of ip, that is given by hp mod mp, and you have to compute x of ip, that is given by xp mod mp. So this can also be easily calculated. So x of 0p will be equal to h0 plus h1 plus h2 plus h3, and that can be denoted as h subscript 0 and superscript 0. So this subscript is for power of p, that is 0, and this superscript is for the corresponding term. h1p is h0 minus h1 plus h2 minus h3, that can be denoted as h0 of 1, p raised to power 0, and term corresponding to I equal to 1. H of 2p is h0 minus h2 plus h1 minus h3 p. So this can be written as h of 0 2, because this is not having any factor of p, and this is p raised to power 1, so this can be written as h of 1, p raised to power 1, so 1, and the value of I is 2 into p. Okay, so similarly you can calculate the value of x of ip. So x of 0 p is x0 plus x1 plus x2 plus x3, that can be denoted as x subscript 0 superscript 0. X of 1p is given by x0 minus x1 plus x2 minus x3, and that can be denoted as s subscript 0 superscript 1, and x of 2p can be denoted by x0 minus x2 plus x1 minus x3 p, so that can be denoted as x0 2 plus x of 1 2 p raised to power 1, so that is why it's 1 dot p. In the fourth step, you have to compute s of ip, that is equal to h of ip dot x of ip mod m of p for I equal to 0, 1 and 2. So s of 0p is h of 0p x of 0p, that is equal to h00 x00, that can be represented as s subscript 0 superscript 0. S of 1p, that can be represented as, that is equal to h of 1p x of 1p, that is h of 01 x of 01, that is equal to x of 01. Okay, so this term h0 x0 and h1 x1, the power of p is 0. Okay, so if we take the mod by mp, so the remainder will be the value itself. That's why I have not written mod of mp at this point and directly substituting the value. So s2p can be written as h2p dot x2p mod of mp, and writing the value of h2 of p, that is h0 minus h2 plus h1 minus h3p, and x2 of p is x0 minus x2 plus x1 minus x3 of p mod p4 minus 1. So the degree of the modulus is 4 and the degree of the polynomial is 2, so the remainder will be the value itself. Okay, so this is h0 of 2 plus h1 of 2 p, and this is x0 of 2 plus x of 1 2 p, and multiplying the, opening the bracket, multiplying the terms and rearranging, we have this h0 of 2 as x0 of 2 minus h1 of 2 x1 of 2 plus h0 of 2 x1 of 2 plus h1 of 2 x0 of 2 dot p. So this can be written as s0 of 2, since plus s of 1 2 p. So the power of p is 0, power of p is 1, and second is for value I equal to 2. Okay, so now talking about the number of multiplications, this require one multiplication, evaluation of s1 of p requires one multiplication, and the evaluation of s2 of p requires 1 2 3 and 4 multiplications. Okay, so if we rewrite s of 2 0 as h0 x0 2 minus h1 2 2. Okay, so this is the value of s of 0 of 2, and if we rewrite this in the form h0 of 2 x0 plus x1 of 2 minus h0 of 2 plus h1 of 2 dot x1 of 2 outside the bracket, and s1 of 2 is equal to h0 to x1 of 2 plus h12 x02. So if I rewrite this as h0 of 2 x02 plus x1 of 2, this is same minus h1 minus h0, that is 2 and outside x0 of 2. So now the number of multiplication is 1 multiplication for this, 1 multiplication for this and this is same, and 1 multiplication for this. So total number of multiplications are 3. So just by rewriting this in a different form, the number of multiplications is reduced to 3 from 4. Okay, so in the matrix form we can write s0 of 2 s1 of 2 on the left hand side, that is equal to, okay, so I am directly writing the decomposed form and leaving a 10x and leaving as an exercise for you, that is h0 of 2 0 0 0 h1 of 2 minus h0 of 2 0 0 0 of 2 plus h1 of 2, and x0 of 2 plus x1 of 2 in the second row, x0 of 2, and in the third row x1 of 2. So it is very easy to decompose this. Okay, now SP, the last step, computing SP, that is given by formula I equal to 0 to 2 summation s of I that we have calculated, n of I that is also calculated as a function of P, capital M of I as a function of P, and mod MP. Okay, so substituting the value of s of ip, n of ip, m of ip for I equal to 0, 1 and 2. Okay, and again this degree of this, the condition is that the degree of this term is less than mp, so the mod value will be this polynomial itself. So the resultant terms will be s0 of 0 p cube plus p square plus p plus 1 divided by 4. Now substituting the calculated values, 1 s of 0 1 p cube minus p square plus p minus 1 divided by minus 4 plus s of 0 2 and p square minus 1 by 2. So I am directly putting the values. S of 1 2 is p into p square minus 1 by minus 2. So that will be equal to s0 of 0 divided by 4 plus s of 0 1 divided by 4 plus s of 0 2 divided by 2 plus p s of 0 by 4 minus s of 0 1 by 4 plus s of 1 2 by 2 plus p square bracket s of 0 by 4 plus s of 0 1 by 4 minus s of 0 2 by 2 plus p cube s of 0 of 0 by 4 minus s of 0 of 1 by 4 minus s of 1 of 2 by 2. Okay, so this can again be represented in the form of matrix. So we have s0, s1, s2, s3. So since this is a circular convolution 4 cross 1, so in the left hand side we have 4 terms, and sp will be given as s0 plus s1p plus s2p square plus s3p cube. Since it is a circular convolution, so the result will have 4 terms, and that is equal to 1 0 minus 1 0 1 1 1 minus 1 0 and 1 minus 1 0 minus 1. And in the column matrix I have s0 of 0 by 4, s0 of 1 by 4, s0 of 2 by 2, and s1 of 2 by 2. So again I am leaving this as an exercise for you. Just you have to decompose this. Just you have to write this s0 plus s1p plus s2p square plus s3p cube. You have to equate the corresponding terms and you have to decompose into matrices in step by step. So this will be the result. Okay, further you can expand this by putting the values of s0 of 1, s0 of 0 and all the values, and you can further decompose the matrix, and the final result will be, I'm directly writing, so this will be the final form. Okay, so total number of multiplications required are 1 2 3 4 5. So multiplications involved are 5.